Hello and welcome back. Now that we have Python and Wing IDE 101 installed, we're ready to begin programming. In this short video, we're going to look at the Python shell and our first programming constructs in Python, expressions, including values and types. The Python shell is accessible to us down here at the bottom left of Wing IDE 101. And what it does is it provides us a very simple interface for accessing the Python engine. The Python engine is simply a program that interprets whatever instructions the user sends to Python. So it's essentially the implementation of the language. So if the user types an instruction of some form into the Python shell and presses return, that instruction is sent to the Python engine, which interprets that instruction, and that may result in some output being shown to the user. So we'll have a look at that today, including using some very simple programming constructs, expressions. So how does the shell work? Well, it just repeatedly reads whatever input the user types. When the user hits return, it then evaluates the meaning of whatever the user typed. Today it'll be expressions, and it prints the results of that evaluation if anything is returned. So very simply over in Wing IDE, and you can do this along with me if you like, and experiment with other alternatives, I can write a very simple expression here. 1, I'm providing the integer value 1 to Python. When I press return, it's sent to the Python engine, and it does a computation to see what's the value associated with this, and it just returns the value 1. Unsurprisingly, a slightly more complex computation, 1 plus 1. I think you'll be unsurprised to see that when we send this expression to the Python engine, it calculates the associated value, which is 2. Slightly more difficult, if you like, not for the Python engine, but for us it would be. If we try multiplying 4, 5, 6, 3, 4, 6, whatever those numbers are, it doesn't really matter, by each other, the Python engine will do the computation when we press return, and then it's just back to the command prompt, that triple arrow you see there, waiting for more input. So expressions are just something that can be calculated to yield a value. And they're typically a combination of operands and operators. The operands are the data that we're working on, and the operators are the types of arithmetic, and for now, operators that we're wanting to be involved in that computation. So with the example we've got on the slide there, 25 times 3 minus 5 divided by 7, that is going to be, when I press return, it's sent to the Python engine, which interprets the expression, computes a value, returns that value, and prints it out at the display. So the value that it's calculated there is 10.0. Okay, so the expression evaluates to 10.0. In Lab 1, you'll come across a variety of arithmetic operators, including plus, minus, multiply, divide, slash slash, which is integer division, star star, which is exponentiation, and modulus division, which is the percent character. Exponentiation is raising to the power. So 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, and so on. Okay. Importantly, there's no space in the middle there. So if we were to try to do instead something like this, well, spaces carry meaning in Python, so this is going to give me an error. And that's what an error looks like. It's telling me there's a syntax error in 2 star space star, because it can't know whether that's supposed to be a mistyped exponentiation or a missed operator involved in a multiplication. So you've got to be precise when you're programming. Spaces can and do matter. Division, we've got 2 different flavors of that, if you like. We've got normal division, if you want, which looks like this. The slash operator gives us division. 26 divided by 3 gives us 8.666666. So what's happened here is two integer values, two whole numbers with no decimal point component to them, 26 and 3, have been involved in an expression computation, and that expression computation has resulted in a floating point value with a decimal point. If I really wanted to keep these values as integers and have them treated only as integers, I can force integer division by using a different operator, the slash operator, and this gives me integer division. So 26 integer division 3 treats both as integers and throws away, if you like, the floating point component. We've also got modulo division, so 26% 3 calculates the remainder associated with any division. So the remainder of dividing 26 by 3 is 2. It's very important that we understand the precedence associated with different operators, because this determines the order in which computations within an expression are calculated. Exponentiation ** has the highest precedence, meaning if an expression contains an exponentiation operator, it'll be performed before all of the other components. Then there's a series of operators with equivalent precedence: multiplication, division, integer division, and modulus. And then we have another set of operators with equivalent precedence: plus and minus. There are also many other operators that we'll introduce later in the course. When an expression contains a multitude of operators, all of which have the same precedence, the order in which they're computed is left to right. Usually, but not always. Exponentiation actually disobeys that order. But normally left to right order is sufficient. So this has important implications for us. So as we see down the bottom, 2 plus 3 multiplied by 5, you might want to predict what the answer of that is. You might think that it's going to be 2 plus 3 left to right. Do that computation. That gives us 5 times 5 gives us 25. But that would be wrong. It gives us 17. Why does it give us 17? Well, it gives us 17 because the multiplication operator has higher precedence than the addition operator. So 3 times 5 is computed first, giving 15, and then the lower precedence operator, the addition, is applied with a plus 2, which gives us 17. So 15 plus 2 is 17. If we really intended the meaning that expression should give us the value 25, the way we would do it is use parentheses to say, hey, let's change the order of precedence here. So 2 plus 3, that's now saying, do that computation first, return the value associated with it, and then combine it with the multiplication of 5. So this will now give us 25. And those of you who are familiar with electronic calculators, you'll be familiar with this type of computation. Okay, I've already started using the term types in a few places. I've talked about the type integer and the type floating point. So values are objects in Python. One is actually an object. In fact, everything in Python is going to be an object, as we'll learn later, and that'll make more sense to you. So every value has a type associated with it. Minus 82 is an integer. It's a whole number. 657,567 is an integer value. And anything with a decimal point after it is going to be a floating point value. Although it's peeking ahead to the future a little bit, we can see we can actually use a function built into Python. Don't worry about this too much for now. But we can ask, what is the type associated with different values? And we'll see here it's telling us that 1 is an int. And if I say, what is the type of 1.1, it's going to tell me that that's a float. And it's saying class int and class float. All you need to know for now is that Python has a very important interpretation of the types associated with the values that it's working with. I could say type hello. We haven't introduced strings yet, but look at this. It's telling me that it's a class string. So all of these values, hello is an object, 1 is an object, 2.3 is an object. These values are objects, and those objects have types associated with them. Every type permits a certain set of operations. Much more on this later. We're sort of looking forward to the future now. But so far, let's focus back to the slide. We're seeing that we've already introduced 2 number types, whole number types like 28,196. When it's a whole number, it's an int, it's exact, and it can be arbitrary size and accuracy. So I can have whoops, if I don't type characters, I can have some huge number, and it's simply going to reflect that number to me, and I can use that huge number, provided it remains a number, in an expression, and it does the computation for me. Okay, those are integers we're looking at right there, and integers are arbitrary size and accuracy, and they're exact. Floating point values, they have a digit associated with them, and I can say, what's the type of this value? It's of class float, so you can see that Python knows that those things have a type associated with them. But importantly, floats have limited accuracy. They're approximate. They're only about 16 digits worth of accuracy. So sometimes they can be reflected precisely, like 1.5 has an exact value associated with it, has an exact representation. But you mustn't rely on exact representation of floating point values. One quick example why here. Imagine 1.1 minus 1.09. Hopefully most of you can calculate the result of that expression. It should be 0.01, right? But because floats are not represented precisely, that's actually not the representation that we'll have. Almost, but not quite. Rather than 0.01 being the value, it's 0.01000009. Okay, so floating point values are not stored exactly, and that's just a limitation of computing. We can get more accurate representation using other types, but we'll come to those much later. Okay, that's it for now. The next video will be on assignment statements, an extremely important video. So make sure you're focusing well for the next video. Thanks.